In this video, we introduce a very important concept in communication system. That's the bandwidth of a signal. It is defined as a difference between the highest positive or highest positive significant frequency and the lowest positive or lowest positive significant frequency in the signal spectrum. So notice the definition is in the spectrum, which means that we're talking about in frequency domain. So to deal with bandwidth of signals, we need to know the spectrum. In other words, we need to know the Fourier transform of the signal. For example, the bandwidth of a signal sinc function is 0.5. Why? Because a sinc t, that's Fourier transform, that's pi of f. Pi of f, we need to plot it. So we want to plot a lot of spectrum in frequency domain. And that's half and minus a half. That's 0. The definition of bandwidth is the difference between the highest positive frequency, that's half, right? The highest positive, and the lowest positive frequency. There's no lowest positive, here is 0. Therefore, the bandwidth is this much, half hertz. Please note that if the lowest positive cannot be found, then the bandwidth is defined as the highest positive frequency. For example, here we look at cosine 20 pi t with the Fourier transform. That's half the f. The frequency here, that's 10, right? Minus 10 plus delta f plus 10. So if we plot it, f, that's 10, that's minus 10, that's 0. So the frequency is here from here to 0, DC. So therefore, the bandwidth is 10 hertz, not 0. Some will argue, okay, because of the delta function, there's no bandwidth in the delta function. Yes, that's true, but that's the delta function is sitting at 10 hertz here. So therefore, this sine, cosine signal, sine zero signal still have bandwidth. It will occupy 10 hertz.